Hey guys, so I recently identified kind of a minor issue annoyance with one of the open source libraries that I'm maintaining. It's the QUAF library, the quantities for Fortran library, and so there was an issue with it that I was kind of struggling with, and it hit me recently that this was the perfect place to implement an example of a modern software development technique and principle that I've been talking about and apply it in this real world situation. And I just got done implementing it. And so I wanted to show you guys both how I identified this issue and then kind of how I applied this principle to solve it. And so the principle that we're going to be using is called the open close principle. The open close principle states that a program unit should be open for modification or open for extension but closed for modification, meaning users of this module or unit should be able to extend its functionality in ways that it will be important to them, but without having to actually change that module's source code. So let's dive into this, and I'll show you kind of how I did it. So I've got open a terminal window and an editor. I'm using the Atom editor, and I've got the source code up for one of the modules that is in the QUAF library. We're just going to start with the mass module, and all of the quantity modules in this library are pretty much identical. So this will apply for all of them, and the fixes was applied to all of these modules. So the basic idea here was that I was supporting some various formatting aspects of how you might want to convert a quantity into a string or convert a string back into a quantity, right? Because it's a number with some units associated with it. And so I was supporting some various formats for that. But it just wasn't quite the right way to do this. So to identify the problem here is we've got a mass type, which is to represent a quantity that is a mass. So it's got the units associated with those. They happen to be stored in kilograms here, but you could convert it to whatever units of mass that you wanted. Is the idea. So one of the things that you might want to do with one of these quantities, just like if you had just a plain number, you might want to convert it to a string so you could print it to the screen or put it in some output file somewhere or what have you. So we want to support something for these quantities as well. And so in order to do that, I had a two-string type bound procedure that we'd want to use, and it had a couple of different interfaces for it, where you might want to be able to specify the precision that you want the number to be output in, or you might want to specify specifically the units that you want it to be output with. Right, so I may not want to output it in kilograms. Maybe I want to output it in pounds. You want to be able to specify the units that it should be output in. But you'll notice that I started to end up with a variety of different two-string functions that were kind of different formats that I might want the units or the whole string to have based on different use cases. Right, so maybe I wanted to put something into a new plot script, and so I wanted to have the units formatted so that something special might happen with those, or maybe I wanted to put some of the outputs into a LaTeX document, so maybe I want to have those formatted properly for that. So I was starting to support a variety of different formats, but it was kind of getting explicit about which formats I was supporting. And it was clear that this was going to become an issue if I kept down this path, because maybe somebody else wants a different specific formatting or the various things like that. And it also was forcing any users. This was already possible for users of the library to be able to specify their own units they just needed to specify a conversion factor and a symbol for that unit, and then they could use their own units in their own programs or projects without having to come back to this library and actually implement that unit being supported in this library. They could just use their own. But it was starting to force the users of that to also support the different formats that I supported, whether or not they intended to use those formats in their own project. And so we kind of start to see this, like, we want to support various formats for the output or inputs, for that matter, but we don't really want to burden our users to have to support all of those various formats and units if they want to have their own units. So what we start to notice is now we can start to notice what are the common behaviors that we're wanting to do here. Well, no matter the format, we want to take a quantity and convert it to a string, and we want to take a string and convert it back to a quantity. In this instance, a mass. So what we notice then is that where is the place that we would like to specify that format? Well, naturally the formatting we really want is specific to the units. Right? The number will be formatted basically with whatever precision the user wants. And so that's a common no matter what. But depending on the units, we may want to format that string that's constructed differently. So that's the place where we now want to say, okay, now we've identified the common functionality and what we might want to attach it to. And it's going to be the unit. So we're going to want to attach this functionality to the unit. Whereas before we can jump down to one of these functions. If my jump to definition will work. Well, apparently it won't, but we'll run down here to one of these functions and show how this was working. Right? So basically what this was doing was the quantity itself was trying to support these different formats. And so that was where we were specifying the format of the string that would be created. But what we want to do is we want to migrate that functionality into the units so that the quantity doesn't have to worry about the format anymore. And so that's kind of the process that we're going to go through. And another aspect of this was I was really only kind of sort of supporting the different units formatting for the different units, or different formatting for units. I wasn't actually supporting that on taking a string and converting it to a quantity. I was only supporting the basic format for that. But if we want to have this really supported properly, then we can attach that functionality to the units as well. And so it is the unit's responsibility for taking a quantity and knowing how to format the string that we want, and taking a string and converting that back into a quantity. And so that's the aspect that we want to end up with here, is we want to take this functionality about how we parse a string and convert it into a quantity, and how we take a quantity and we produce a string representation. So what we're going to do is we want to go back to this. So the way that we're going to implement this is we want the quantities to support any units, and we want to attach a certain functionality to the units. So the way that we do this is we need some sort of an interface specification for how this is going to work. So what we want to end up doing is we want an abstract type that is basically the base class kind of interface specification for how does a unit work. And then the quantity itself will only work in terms of that abstract interface specification. It will not concern itself with the actual implementation about how any of the formatting is done, which is the things that we now want to make a responsibility of the unit. So this was what I started with. So let's now check out what we ended up with. Git checkout master. All right. So now we can see what is it that we actually ended up with here. All right. So now we have an abstract type for the unit. It still needs a conversion factor. So that's part of the interface specification, is that a unit has to have a conversion factor. But we notice that the rest of these procedures are now deferred. They do not have a default implementation. We've just specified what their interfaces are. So there's basically three things that we want to be able to do with a unit. We want to be able to take just that unit and get its string representation. We also want to be able to take a quantity and given a numerical value for that quantity and the unit, produce a string representation of that. And we also want to be able to parse a string with a given unit and produce a quantity. So now we have this abstract interface block. So we take that, so we now specify exactly what the interfaces for these various functions is going to be. So if we want to have just the unit and we want to get a string representation of that, well, the interface is pretty straightforward. It just takes the unit and it produces a string. If we want a unit with a value, right, so now we have a quantity, we want to take that quantity and convert it into a string representation with these specific units. Now we need also a string that is the value that is the representation of the value from that with that unit, right? And lastly, we want to be able to parse that string with this unit, parse a string with that unit, and that might produce some errors. So that might fail. It might not be the right units, or the string might be malformed, or whatever. So that might fail. So we also have an output here that is the errors that might occur there. So now we've just defined an abstract interface, and now we no longer need a variety of two string type-bound procedures for the quantity. We just need one. And what we've done is we've just provided a default implementation for those, which uses, now we have a default implementation that is kind of built in. So in the default case, if you don't specify the units, we'll have a default implementation and some default units that we'll use. But the actual logic and implementation, which is going to be one of these final two string routines, those do not work in terms of units. We just have one interface which just provides the default units. And so now we can go and start to take a look at those, right? So now what are we going to do when we want to create a string? So as I said before, we have the default implementation, which doesn't require a unit. So it's just going to provide a default unit. And similarly, if we want to specify the precision, it just needs a default unit. But the actual implementation, when it wants to create the string, it takes the unit that is specified, which is now of the abstract class, the abstract unit type. It uses that unit's toString function, and it passes the string representation of that value, so the numerical value produced in those units. So for example, if I wanted to get, if I had a mass that was, for example, 1 kilogram, but I wanted to output the string in pounds, so this converts that mass to a number in pounds, converts that number to a string, and passes that string number to the toString function of the unit. And now it is the unit's responsibility to take the number and do whatever formatting it would like to produce the string representation of now this quantity with that unit. So when we have this simple, so our default implementation, the simple units, now we can start to see how that gets implemented. So for a simple unit, it's just got a simple symbol associated with it. If we just want the unit as a string, the string representation of the unit, it just takes the symbol and just produces, it just gives that as the string representation. But if we're given a value, well, for the simple case, we'll just put a space between the value and the symbol. But things really start to get interesting when we start to look at how we parse a string into a quantity, right? So whereas before we were only supporting the simple format for parsing a string to a quantity, now it is the unit itself's responsibility to do that parsing. And so what we can do is we again have the defaults where we may try with the provided units, but we also may be given a set of units to try to parse this value into a quantity. What we do is we just loop through all the possible units that this function has been given. So we'll try and parse that string into a quantity with that unit. And if it doesn't produce any errors, then we know that that is the unit that string was specified in. And so we can return the quantity with those units. Right? So if it didn't return an error, so this mass value now has been returned with the proper value now, and we can just return from this routine. But if we finish this loop, we never hit this return statement, then we know that we weren't able to successfully parse the units or the value with any of the units, and so we're just going to return all of the errors that we got from trying to parse every single one of them. So now the user will be able to specify the units that they would like to, the formats, by giving their own units that they would like to try and parse this string in, and they'll get all of the errors from all of the possible units that it tried to parse with. So in the default case, if they don't specify the units in the format that they would like to use, we've got some that are provided by the library, and it will use those. And so now so the simple case, the user doesn't have to worry about trying to do the extensions. We've got something provided for them. It will work for them, and they'll get their error messages will be, here's all of the ways that I tried to parse this value. Here's the errors associated with that. But advanced users can specify their own custom units that have their own custom formatting and parsing capabilities, and the same routines now work for both. So now we've satisfied this open-closed principle of this module is now open for extension without any modifications being necessary in this module. Right, and so now we can do an interesting thing. We can take a look at what's the simple way that we try and parse it. Right, so we looked at how we converted to a string where we need that's now the unit's responsibility. Here's how it converts a value to a string. So how does it parse that value? I used another library of mine, which is parf, which is a parser combinator library. Right? So we need to specify a parser for this. And it's just going to try and parse that string with this parser. Right? And then it'll do the error checking properly. So what does the parser look like? So we're going to try and parse the rational part, so that's the numerical part of this number. Then drop the space, and then drop the unit. But how do we parse the unit part? Right? So this is the simple case where you've got a number, a space, and then the symbol for the unit. So now each unit has its own parser. By putting the function inside this, by putting this function inside this routine, it has access to the unit that this parser is being run with, and so it can try and parse it with the symbol for that unit. So what ends up happening is it tries to parse. So the parsing logic is exactly the same for every unit. It's just that the symbol happens to be different. And so if the symbol matches what's in the string, this parser will succeed. But if it doesn't, it won't. But the parsing logic is exactly the same. Right? And so we also want to support given a string, how do we figure out which unit that string represents? And we don't even need an interface specification for this part that is a part of the unit type. We can just say in an abstract sense, if we're given a list of units and a string, well, we'll just see if converting that unit to a string matches the string we were given, and we'll just return the index in that array. Right? So it doesn't really work very well in Fortran trying to return abstract types. Doesn't work very well. But in this case, I don't have to construct that type. I already have an array of them. I'll just tell the calling routine, hey, use this one. And so now for the default case, now we can in an interface specify these to all be using the same name, and it will be based on the specific type that we're trying to, of the units that we're trying to get back from this string. So in the default case, we're going to try and use that from the select unit to figure out which of that list does this match. And if it doesn't match any, we get all the errors back. So now we can see how we've implemented this in the default case. But you'll note, if you were paying attention before, when we were actually supporting various different formatting types, now those types are no longer a part of this library because they don't have to be. So now somebody who doesn't want to use any advanced or other different types of formatting for their units doesn't have to worry about supporting those if they want to create their own units, or worry about the fact that there are other options available to them in terms of parsing, formatting. So, but what I did was I extracted that functionality into separate libraries. So, for example, for the new plot formatting, we now have its own standalone library, which just contains the units. It contains another type, which is which extends from this abstract base type, and it just needs to implement its own versions of these procedures in order to now support different formats. And so we can take a look at what one of those might look like. We can again just go take a look at the mass units. Right, so now what we can see is looking in this, we just have another type that extends from the abstract mass unit type. Now we just have our own versions of these routines. We again still need a symbol, but now we can specify our own units with this. We can basically specify all of the same units, but now somebody who passes these in for formatting or parsing, we use these formats. In this case, they're actually identical to the simple format, to the default that we were supporting in the main library. But let's go take a look at the more complicated units or formats, which were the tech units. So if we're formatting for use in LaTeX, we actually don't want just a number space symbol. What we actually want is the LaTeX commands with the appropriate number and commands for the units inserted into that format there, right? So in this instance, we actually don't really want to support all of the same units that are supported in the main library. So whereas before we were kind of forced to put something in there for a symbol for the LaTeX units because we had to support that formatting. But now we can say, well, actually, if we're going to put this into a LaTeX document, these are the only units that the LaTeX actually will support. So these are the only units that we want available. So somebody doesn't specify one that actually isn't supported. Now we can have this level of granularity as well, of like, now we're only supporting formats and we're only supporting units for those formats that actually make sense. But again, somebody who doesn't need LaTeX formatting doesn't even have to worry about the fact that this library exists. They can use the simple default case and that works just fine. But things do get interesting in here, so it's worth taking a look at. Of now when we implement the necessary routines for this new type, you'll notice that what we're actually going to do is we're going to wrap this. We're going to actually use a helper function that we've written to do something different for formatting the value in the units. We've got this wrap in LaTeX quantity routine, and we can go take a look at what that is. It's relatively straightforward, but we can go look in the module that contains that, where it's just got wrap in LaTeX quantity, which basically it's just got the number and the units, and it just wraps it into the appropriate LaTeX syntax so that this will work and render properly. Similarly with the units, when we want to get a string representation of just the units, there's again a LaTeX command that we want it to be wrapped up in. And so now we can support a completely new format, and we can specify only the units that we really want to have supported without having to worry about impacting any of the other users. And so again, we've got this open closed principle now satisfied. The library is now open for extension without any necessary modifications. So I hope this was informative. I hope you learned something. And I hope now you've got a new tool in your toolbox for how you can structure and write more extensible, maintainable, understandable Fortran code.